उस पे वेक्टर फील्ड हम कंप्यूट करेंगे।
हम ये कह रहे हैं the total curl of f on S is equal to the circulation of the f along the curve C. So since C is closed, actually think about it. So if f is moving, okay, so it's like f is okay, so what we call flowing across the C actually. Okay, so you're gonna say that so here's the thing actually. Okay, so see something that is so see the curl in water actually. Think about it. So if you have a more and more curl in the region, okay, that curl will be reflected from the boundary actually. Okay, and that's what gives the connection. Okay. So the net curl of f onto the surface is same as the circulation of f, roughly the curl of f, okay, not really the curl, but circulation is a better word, of f along the entire curve. Okay. Along the entire curve.
सर उस कर्व पे सर कर्व कैसे आएगा सर? बाउंड्री
नहीं, कर्व नहीं है ना बेटा, so I'm not calling a curve. So f is defined on it, f is defined on C. So I'm saying that how the f is circulating. If f is curling inside the region C, so I'm going to say that sum this up, this would be equal to the curl of f along the entire curve. See, not the curl, but the circulation of f along the entire curve. So I'm not going to call it a curl, but it's really a circulation of f along the entire curve C. Just think and ponder over it. It's really the Green theorem with a bit more dimension actually. Anyway, ठीक है नहीं sir? Are we happy with it? Good. So let's take a surface and let's compute its surface integral, the surface integral of the curve. Okay. So if you want to compute the surface integral of the curve, you have to compute the double integral, okay, of u of f of p uv dotted with pu cross dv. ठीक है? And dv. So very simple thing. ठीक है? Now here is an identity. You can see the proof of identity from the book I'm just mentioning. So if I have a del cross f and its dot product with some vector a cross b. Okay, so the identity goes like this. Then this is same as a dot del operated onto f and its dot product with b, okay, minus b dot del operated onto f and its dot product with a actually. That's what is going to be. You can see the proof from the book. But what is a dot del? Or maybe what is the meaning of this expression? I mean, if you like to see it explicitly, that this will be like this. So a dot del is really, so a is a vector, so it's going to have components. So by a dot del operated onto f, I mean that I have this a1 partial by partial x plus a2 partial by partial y and plus a3 partial by partial a3, yes, partial by partial z, so that's my, and then I'm operating it onto f. Okay. So what is the meaning of operating onto f? So take this operator and operate onto each component of So it's going to produce a vector and then take the dot product of that vector with. Okay. So that's an identity. You can ponder over it that what it should be, why it should be true. So I'm going to use it. Okay. It's a difficult identity to do. You just have to, compute both sides and see what you get. It's a bit computational, but yes, it's easy to do. Alright. So can you see that I have something like similar here?
Yes.
I have
C
something
is like
similar.
A and P is like this.
I have something like similar. So this will be equal to double integral over u. So I can say that this is going to be same as pu dot del operated onto f and then dotted with PV minus PV dot del operated onto F. So this is reading is also important actually, that how one should read in a statement. Okay. So I have this PV dot del and that's an operator. So it's operated onto F and then taking its dot product with this is one of the identity. Now, what is pu dot del? So the pu dot del. So that if p, for example, takes values x, y, z. So in other words, p is a map that takes values, for example, x, y, z. While x, y, z, they all are the functions of u and v. Okay. Then pu is going to mean what? xu partial by partial x plus x yu partial by partial y plus
ZU.
zu and partial by partial z. Okay. So that's an, what do you call, operator where. Okay. By the way, if you see this, when you see this, do you see something interesting? What is this? So this is chain rule actually. Partial x by partial u and then partial by partial x and partial, partial y by partial u and partial by partial y. So it's really the chain rule. So chain rule representing what? So you can say that this is nothing but it is, the partial by partial u. So I have something that depends on x, y, z, where x, y, z depends on u and v, and I want to compute its derivative with respect to the u. So that would be the recipe to compute it. That first you differentiate it with respect to the x, okay, partial x by partial u, and just compute it. So you can say that in a differential notation, this is just the derivative of the u actually. Okay, but it's not a simple partial derivative, but it's a partial derivative of of u with respect to u of something which does not directly depends on u, but it depends on x, y, z, and x, y, z depends on u actually.
So here we are just mentioning that it's partial with respect to partial u, but what are partial of what?
So that's like an operator actually. Okay, so here, for example, I'm going to operate it onto f actually. So I'm going to operate it onto f. Okay, so I'm going to operate it onto f. So I'm going to say, so I'm going to operate this entire operator onto f actually. And f, I know that it depends on x, y, z.
And so for similarly, PV dot
Yes. It's just a bit of. And now think over pu dot del operated onto f. Okay. Pu dot L operated onto F. So by pu dot L operated onto F, where F is really depending on x, y, z. ऐसा ही है ना? So it really depends on x, y, z. And x, y, z is what? I can, if I write this F as P of uv, while the P of uv is a map that takes uv and throws it in R3, so it becomes x, y, z. Okay, so f of x, y, z is really f of p uv, and then this operator on f is really like computing the partial derivative of u. So if you have to write, if you're gonna write f in the terms of x, y, z, you have to interpret it as like this operator. But if you are purely writing it in the terms of u and v, then you know this operator really means that you need to differentiate it with respect to simply u. समझ आ रही है बात? थोड़ी सी हल्की आंच पे.
Sorry, last step.
Second last.
So I have this f. So f is defined where? So it's defined on S, you can see. So roughly f takes a point of 3 dimension and it throws it onto a point of 3 dimensions. So it takes a point x, y, z, where x, y, z is a point on the surface. Okay? X, y, z is a point on the surface. But I know that this point on the surface x, y, z is a consequence of a point uv from the domain at least. And then you apply p on it. And I'm saying that I'm operating this operator onto f. Now I'm saying that you have two ways to compute this. If you want to keep f depending on x, y, z, where x, y, z are the functions of u and v, then this is the meaning of, you know, this operator being operated on f. But if you for example, you know, write f purely in the terms of u and v, this is simply the partial by partial u, because you know, this operator can be interpreted as that you have something and you are differentiating it with respect to the u. But that something does not directly depends on u and v, it depends on, for example, functions x, y, z, and so. ठीक है? थोड़ा सा और करेंगे तो समझ आएगी बात. ठीक है? And I can also write this as f composition p and its derivative with respect to u. That's what it means. That's what it means. ठीक है? अब आते हैं this integrand. So let's get to this integrand. Let's try to make sense of this integrand. What does this integrand say?
We'll take difference.
So I have this pu del f operate dotted with pv minus pv dot del operated onto f dotted with u.
Again, composition.
Now this is what?
So again, f of p of
P of
That's f of p of u. So f composition p dotted with u and its dot product with v minus this is f composition p, its partial derivative with respect to u and dotted with u. ठीक है जी? And now I want to take an interesting step. Okay? And this interesting step is this. So just to make sense of it, that how I'm writing the next step. So take F composition P, okay, is going to be a vector. Okay? So F of P of U is a vector, and dot it with PV. Okay? And dot it with PV. So when you're going to dot it with PV,
Then take the partial derivative.
take the partial derivative now. Okay? Now if you're going to take the partial derivative now, what are you going to get? You're going to get two terms coming out of it, because you're going to apply the product rule. So the first term is going to be F composition P U dotted with PV plus F composition P dotted with PVU, for example. ठीक है?
ये इसका जो है दो टर्म पहले के होंगे, दो टर्म बाद वाले होंगे, तभी वो प्लस होगा। तो इसका एक ही टर्म होगा ना सर?
क्या मतलब?
ये जो हमने लिखा है f of p।
अभी आता है समझ में. So are we happy with it? And I'm saying, what would be this? So I can treat this as a difference of these two terms. कह सकता हूँ. So this term, so if they are equal, I can treat this as the difference of these two terms. ठीक है?
Yes.
So if you're going to take, so what would be the first term converted into? So I just knew that this is same as F composition P dotted with PV taking partial derivative U minus, ठीक है? F composition P. So what's the benefit of it? We're going to see a benefit in a minute. Dotted with PVU. Okay. Dotted with PVU. And what would be this? Similarly, equal to F composition P dotted with PU differentiated with respect to V minus F composition, the plus basically, F composition P dotted with ठीक है? Are we happy with it? ठीक है? अब these two terms will go away. Why they will go away? Because P is smooth. So if you have a smooth map, then the order of derivative doesn't matter. They are always equal. They are always equal. ठीक है? So you come up with these two terms. Now this term I'm calling it Q. So I want to apply the green theorem actually.
Yes, it's a Q and it's a P. Q minus
So call it Q, the first term Q, U minus QV, or PV. QU minus PV. So let me call this Q and let me call this P. ठीक हो गया? घबराना नहीं, घबराना आप लोग ठीक है? It's fun to know that how it's going.
Well, Jack.
Okay. Note it down, and if not, you can open your book and keep the proof in front of you. But there are some things that are missing actually. ठीक है जी? So now I have something that is interesting. So I have this del cross F du del cross F over S actually. ठीक है? So we started from here and we ended up at double integral, okay? But over what? Okay. So it's a double integral. It's a double integral over the boundary of the u. But what is the boundary of the u? It's or maybe let's define sigma.
The surface including boundary.
Not surface, but the domain including boundary. Because
Yes, sir.
you are choosing u and v from there. And you have what you say qu minus pv and pu dv. Okay? Now, so in other words, I had this long expression with me and I substituted my simplified form here, so I got this actually. So I can apply Green theorem here. So if you're going to apply Green theorem, you're going to get what? This is equal to the integral of the boundary of the sigma, so this is gamma, of what? P du plus q. Okay? P du plus q dv. Now I would like to do what? Just a little bit, just 2-3 more lines, not more than that. For this, I mean, if you want to write it, so what is the parameterization of the gamma? So if you want to write it more explicitly, you need the parameterization of gamma. But we have fixed that, the gamma has parameterization this gamma of t actually. Okay? So the gamma is parameterized by the gamma of t. So as we have assumed that gamma is parameterization of gamma. So first of all, gamma will be mapped from where to where? It's going to be mapped from some interval A to B and throws it in R2. So if you have gamma of t, how does the output of gamma would look like actually? So it's going to be a point on this boundary. But this point on the boundary is a two-dimensional point. And all points in this region we are denoting by u and v actually. So this is going to look like u of t and v of t. Okay? So the u of t and v of t, which are ready to be swallowed by p, to throw them the boundary here. Okay? So I have this integral with respect to the boundary, of this region, but I want a line integral along the boundary of this surface actually, not this region. So I need to convert this line integral into somehow integral over the boundary. Okay? This is what that we would like to have. And you remember by C of t what we meant? We meant it's the parameterization of the curve C actually. Okay? So how can I have C of t? So the C of t, the point on the C of t can be taken that, okay, take the point on the boundary of the sigma and then apply p over it, so you're going to get C over t. So the C of t is going to be something like u of t and v of t actually. Ready with it? Again. Finish it. Let's finish it. Okay, time to run. Okay. Just finish it. Just finish it. Around the year. Just finish it. Take it. So if I want to compute now the derivative of the c with respect to the t, how does it going to be computed? So for this I need to compute the derivative of the p with respect to the t. the P does not depend on T directly, but it depends on U and V. So you need to apply the chain rule. So the C prime of T, okay, basically I want to rewrite this integral. So therefore I'm getting into the tiny details of it actually. Okay. So these are the things that I'm going to use in my really last line actually. So it's dc by dt. So what should be the formula of it? So you're going to say, okay, take your P, differentiate it with respect to U, and take your U and differentiate it with respect to the T. But you can write this as a total derivative because U only depends on T actually. So total derivative को तब लिख सकते हैं. Partial तब होता है कि when U would depends on more than one, but the U only depends on T. Plus partial P by partial V and dV by dt. ठीक है? So you have got it. Therefore I can say that this is PU
and U prime.
U prime and PB
And U prime.
V prime. आओ इसको देखते हैं. Let's see how it turns into our required line integral. ठीक है? The real science is this. You have to learn. When you want to do real science, you have to be always patient at all. Because it's more coming in the future. बातें करना आसान और काम करना बड़ा मुश्किल होता है. So you have to be patient always. ठीक है? चलेंगे. So I want to compute this P du plus Q dV over this gamma. So if you want to compute it, and say if you want to write it in the terms of A and B, so what we need to do? So you can do it by, say for example, dividing by dt, and take this dt, okay, and you will have, okay, so what do you need to do first? So you have to take the parameterization of the gamma, which is going to be P of gamma of t, okay, du of t plus q of gamma of t and dv of t, right? But I can rewrite this as a to b, the p composition gamma, and if I, for example, differentiate with respect to, divide by dt's and dt's, not really divide by dt's and dt's, but you know what I mean. Okay. So you're going to have a u prime plus q composition gamma, of t times v prime and dt. Times dt. This is going to be the case. And now, what is P composition gamma? So what is P composition gamma? So that's Cn. So I have, no. This is capital P. Okay? This is capital P. So you don't have to. Okay, so what was the P? So can someone recall what name we gave to the P?
Yes, sir.
So P.
F of P of UV dot P.
So it was F composition P. Okay.
Yes, sir.
Dot
partial derivative.
PU.
Yes.
Okay. And now I'm saying that evaluate the P at gamma of T. So what is the meaning of evaluating the P at gamma of T? So it's going to be F composition P and evaluate it at gamma of T dot P. As a, they can, so P, so the capital P is this. So what is the meaning of P composing with gamma of T? That F composition P operated onto gamma of T dot P. Okay? Now this P is really that P atom. So what would be the P composition gamma of T? So that's your C actually. So I can write this as, this is same as F composed with C and dotted with PU, and I have a U prime, plus F composed with C, dotted with PV, and multiplied